Hello, this representation about embedded system design, prepared by Abdikarim Zwain and supervised by Dr. Amr Amir. Embedded software. Computers are used to control a wide range of systems, from simple domestic machines through games controllers to entire manufacturing plants. Their software must react to events generated by the hardware and often issue control signal in response to these events. The software in these systems is embedded in the system hardware, often in read-only memory, and usually respond in real time to events from the system's environment. Responsiveness. Responsiveness in real time is the critical difference between embedded systems and other software systems, such as information systems, web-based systems, or personal software systems. For non-real-time systems, correctness can be defined by specifying how system input map to corresponding output that should be produced by the system. In a real-time system, the correctness depends both on the response to an input and time taken to generate that response. If the system takes too long to respond, then the required response may be definitions. A real-time system is a software system where the correct functioning of the system depends on the result produced by the system and the time at which these results are produced. A soft real-time system is a system whose operation is degraded if results are not produced according to the specified timing requirements. A hard real-time system is a system whose operation is incorrect if results are not produced according to the timing specification. Embedded system characteristics. Embedded system generally run continuously and don't terminate. Interaction with the system environments are uncontrollable and unpredictable. There may be physical limitations, such as power, that affect the design of the system, and also direct hardware interaction may be necessary, and issue of the safety and reliability may be dominate the system design. Embedded system design, the design process for embedded system is a system engineering process that has to consider in detail the design and the performance of the system hardware. Part of the design process may involve deciding which system capability are to be implemented in software and which in hardware. Low-level decision on hardware support software and system timing must be considered early in the process. These may mean that additional software functionality such as battery and power management has to be included in the system. Reactive systems. Given stimulus, the system must produce reaction or response within a specific time. Periodic stimuli which occur at predictable time intervals. For example, temperature sensor may be pulled 10 times per second. A periodic stimuli which occur at unpredictable times. For example, system power failure may trigger an interrupt which must be proceed by the system. Stimuli and response for burglar alarm systems shown in table below. If a signal sensor positive, initiate alarm and turn on light around side of positive sensor. If two or more sensor positive, initiate alarm and turn on light around side of positive sensor, and also call police with the location of suspected break-in. If a voltage drop of between 10% and 20%, then switch to battery backup, run power supply test. A voltage drop of more than 20%, switch to battery backup and initiate alarm and also call police and run power supply test. If power supply failure, call service technician. If sensor failure, call service technician. If console panic button positive, initiate alarm, turn on light around console and call police. To clear alarms, switch off all active alarms, switch off all lights that have been switched on. This figure shows a general model of an embedded real-time systems. In the center, real-time control system, and above the center, sensors, and below the actuator. We mean by sensors such as camera and any sensor such as sensor for sound or camera, and actuators such as alarm. Architectural consideration. Because of need to respond to timing demand made by different stimuli or responses, the system architecture must allow for fast switching between stimuli handlers. Timing demand of different stimuli are different, so a simple sequential loop is not usually adequate. Real-time systems are therefore usually designed as cooperating processes, with the real-time executive controlling these processes. This figure shows the sensor and actuator processes. When the sensor passes the sense information or data to sensor controller and then to data processor that execute the data and transfer it into information and then pass it to actuator controller and then to actuator to do the action. System elements. Sensor control processes collect information from the sensors, may buffer information collected in response to sensor stimuli. Data processor carry out mean executing processing of collected information and computes the system response. Actuator controller processes generate control signal for the actuator. Thank you.